What did you get, Charlie Brown?
I got a rock. I got a rock. Rock. I got a rock. 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 I got a rock. I got a rock. I got a rock. Rock.
What did you get, Charlie Brown?
I got a rock. I got a rock. 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 I got a rock. I got a rock. Got a rock.
What did you What did you get, Charlie Brown?
I got a rock. I got a rock. 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 I got a rock. I got a rock. Got a rock. Got a rock. 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 I got a rock. I got a rock. 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 I got a rock. I got a rock.
All right, so today we're going to be starting on the next module for next week, but of course we'll start today on encapsulation. And remember, we are on Piazza, we are on YouTube here, so if you have any questions, go ahead and post there. Just making sure it works. All right, good. All right, so encapsulation, I mean, if you look it up in the dictionary, it's you're encapsulating something. You're taking something and you're surrounding it with something. And in the context of code, that means that you're creating new types. So as you might have seen, the built-in primitive types, the integers, the doubles, the chars, these are okay, but they're not enough, right? Not everything in the real world is just a simple number or a simple character, right? Instead, real world entities are made up of multiple pieces of data, right? So for example, just from yesterday, lab 10, what kind of objects or what kind of entities did you have there? States. States had names, and just for that lab, states had a name and a population, right? That's more than two pieces of data that made up one logical unit. You could, of course, get way more fancy if you really wanted to. The state also has a capital. It also has a governor, blah, 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 right? You could have dozens of pieces of data associated with one state. What about the baseball teams? The other one. You had the team name, I kept it simple as possible. The team name, the wins, and the losses. 3 pieces of data that made up one logical unit. But we never collected them into one thing. Instead, if you remember the code over here, you had to maintain a separate array of strings representing the team names. You had to maintain a separate array of win percentages. And if you wanted to keep track of both wins and losses instead of just percentages, that's yet another array. If you wanted to keep track of the home city, right, that's yet another array. And when we go down here to actually sort things, we have to make sure to do all the bookkeeping ourselves. That if we take the Padres and the Astros and we move them, by the way, this is from 2011 when Astros were still in the NL. But if you had to switch them around, you had to switch around every single thing in all of those arrays. What's the better solution? The better solution would be to take all of these pieces of data that make up a team or a state or a person or whatever and collect them, encapsulate them into one logical unit. And that's what we're going to do with in C. Okay. So again, it was Lab 10 had baseball teams and states. The solution here, it's a bad idea to represent them with a lot of different pieces of data. There's a lot of bookkeeping, manual bookkeeping that you have to do. And also, it's logically, it doesn't make any sense. A team is not just a name. A team is a name, number of wins, number of losses, etc. We want to treat that real-world object as closely as possible to one logical unit in our code as well. We like our code to look like the real world because then we can understand it better. Right? In C, this is generally referred, not just in C, but in many programming languages, referred to as, encapsulation. Encapsulation actually involves 3 things. First of all, it's the grouping of data, the protection of data, and 3, the grouping of behavior that acts on that data. The grouping of behavior or functionality that acts on that data. Right? And again, unfortunately, this is more, all 3 of these elements that make up encapsulation is more of an object-oriented programming kind of concept that came later after the development of C, where C versions of C like C# and C++ and Objective-C, all of these object-oriented programming languages that grew out of C. And they added more and more and stronger versions of encapsulation. Unfortunately, with C only supports the first element, the grouping of data. Now, there are ways that you can hackishly get the other 2. There's no guarantee on it, of course. There are conventions that you can follow to get the protection of data. You can flag a variable as private, you should not touch this, by beginning it with an underscore. You can group functionality with the data that acts on it through what are called function pointers. We'll get to those much later. Don't worry about them. We're just going to focus on the first aspect of encapsulation, the grouping of data together to make one logical unit. Those are called structures in C. In C, we use structures. Okay? So how do I define a structure, first of all? For that, I'm going to go over here, and we're going to play around with it. Now, there are lots of things that you could do. We could do a baseball team if you wanted to. We could do a film. What are the things that we want to model? We could do an album. We could do a film. We could do a book. We could do a student. We could do a lot of different things. Any suggestions? No? All right, then let's do a film. All right. So I want to model a film. Right? I don't know, Dune just came out. Right? So that'll be our motivating film. I have not seen it yet, but the book is old. I've read it a long time ago, so I know everything that's going to happen in it. No spoilers, don't worry. All right, so let's model a film. To define a structure, you use typedef. Where have we seen that before? Enumerated types, Where we defined an enumerated type, where we defined a list. Here I'm defining a structure. And so we use the keyword struct instead. And of course we save on 3 characters. Right? I'm going to give this a name. Well, if it's modeling a film, what should I call it? Film. All right? Or movie, or whatever you want, if you want to call it a movie instead. And I'm going to follow this with a semicolon at the end. Note here that I'm using upper camel casing convention. That's similar to what we used when we did enumerated types. I didn't call this a films. Why? It's not an array of films. It's one thing. It's one blueprint for how you represent one film. Okay? So no pluralization either. Now inside this, when we had an enumerated type, I had a list. This is the first value, comma, second value, comma, third value, comma. What I'm going to put in here are called member variables. These are going to be full variables. So they're going to be like variable declarations, where instead of a comma, you have a semicolon at the end. But first, we need to understand what makes up a film. Like, what's one aspect of a film? I mentioned Dune. What is Dune? The word Dune. That's a title. Okay. All right, title. Now, what kind of variable is title? It's a string. And how do we represent strings in C? Char stars. Okay. What else makes up a film? Actors. All right. That's an S at the end. So that tells me that there's probably some sort of a relationship between these two entities. What's that screaming out to you? What is an actor? A name. Okay. Okay, so what if we did it like this? Char star actor. Let's think ahead like this. How many actors can there be in a film? A lot. So actor 1, actor 2, actor 3, right? That doesn't seem right. I could have an array of strings. But let's rethink this a little bit more. Is an actor just a name? Right? Actor name. Okay. What else is an actor? I mean, even a name. Is a name one thing? What's my name? Chris Burke, right? I have a first name and a last name. 2 pieces of data that belong to one entity. What is that screaming out to you? 2 strings at least, but if I want to group them together, what should I do? Let's make another structure, right? Type def struct, and I'll call it actor. Okay. All right, so let's go ahead and define an actor really quick here. Char, first name, semicolon, char, second name, or last name, semicolon, right? We'll come back to the film here in a second. What else does a person have? An actor in this case. A role, okay, they have a role in the film. But just think of the actor by themselves. They have roles in other films too. Right? So what makes up like this is a person, right? So they might have an ID of some sort, social security number, right? What else? Who stars in Dune? I have no idea. Ving Rhames? Ving Rhames is dead, isn't he? Did you say Ving Rhames? Oh, okay. Kyle MacLachlan then. We're talking about the 1984 Dune. Kyle MacLachlan starred. So Kyle MacLachlan, he's getting up there in years. How do I know how old he is? Age. So how do I represent an age? What if I just did int age? And I don't know, he's 55 years old or something. And then his birthday comes around and he becomes 56. Which one of those things gives me more information? Just his age, a static number, or his birthday, where if I can take that birthday and I can take the current date, I can get that age by doing some math. Probably birth date is a little bit better, right? So how do I represent a date of birth? Date of birth. Could it be a string? Sure. It could be what? 2021, 10, 27, right? What did I just write down there? That's, of course, the year. And by the way, that's the correct and the only correct way of writing down dates. Year, month, day. Americans are wrong. Europeans are wrong. This is the lexicographically correct way of doing it, right? And therefore the only way of doing it. Right? And computer scientists are the only ones that are correct. Right? All right, so what is that? Year, month, day. I counted 3 things there. What is that yelling out to you? Another structure. So type def, struct. And what should I call this? I'll just call it a date. Right? But at this point, I'm going to go back to the very beginning of the semester where we talked about problem solving. What's the very first question you ask yourself when you solve a problem? Is it already solved? In other words, does C already provide a way of representing a date? And the answer is yes. It's called date sub T. The sub T there is type, and it's built in. It might be time T, I'm not sure, but you'd have to bring in a library to do it. I'm not going to get that fancy. I want to demonstrate syntax and concepts here. So there's going to be a year, a month, and a day. What are those 3 things? Integers. Okay, I'll buy that. Int year, int month, int date. Day, right? Because we already have a date. Okay. And now I'm going to come up here and correct this. This is a date type. Date of birth. And now I'm going to come up here and correct this. Actor. Now that we've corrected the problem of modeling this, now let's come back to the original problem. Is there just one person in a film? Not unless it's a one-person show or something, right? So we could do an array of actors, right? I don't want to get that complicated yet, though. Generally, though, there are films with multiple directors. So what we could have the lead actor or something like that, lead actor, or we could simplify this and say that we have a director, not directory, but an actor who is a director. Now I'm rethinking the name of this. What encapsulates misuse of different use of the word encapsulates. So what encapsulates both an actor and a director? They're both people. So person. Right? All right, I'm going to go ahead and use that instead and call that person the director. Right? Does anybody know how films are uniquely identified? Well, you could go to the IMDb and get an ID there. But I think that there's an EITC, is it? EITC, or no, it's EIT Media ID. What is it called? No. Media film identifications. DIDR, is it? EIDR, thank you. EIDR. Thank goodness Safe Search is open. Let's get random internet crap. EIDR. So you can go ahead and search this for various media. I don't know what happens when Dune. We ask about Dune. All right, that's not going to come up. That's probably just searching the website instead of the actual database. Find an EIDR. Dune. Yeah, we're going to get a whole bunch of media with the word Dune in it. In fact, there are at least 6 pages with 25 each. Whatever. Anyway, an EIDR is going to be a string. It's an alphanumeric designation with a bunch of hyphens, etc. So I'm going to go ahead and make that into a character, into a string as well. What was it? EIDR. There we go. So we've got a title. We've got a director. We've got an EIDR. What else could we put in there? Genre, okay. And then subgenre, subgenre, cross-references genre, right? We could get really, really complicated there. A rating, I like that idea, but let's make it a critical rating, like a Rotten Tomatoes rating or an IMDb rating. Let's do with IMDb rating, double. IMDb rating. Internet Movie Database, for those that don't know. All right, that's a good enough for now, right? Of course, you can get as complicated as you want. 4 fields here or member variables is more than enough to get the idea of what's going on here, okay? So let me go ahead and make sure that all my syntax was correct by trying to compile this demonstration here. Demo, there we go, all right? It's not gonna work, right? So, unknown person type, person director, unknown date type. I did them right there, right? But what's the problem? In C, when you have a variable, if you want to use the variable, what do you have to do first? Declare it. So if I'm going to use a person, then the order matters. You have to declare the type before you can use it. Right? See any other problems? Date. If you're going to use the date, then you need to declare it before you use it. Right? Now, there are ways around this, and in fact, there are other ways, at least 2 other ways of declaring structures. Each one of them puts the structure in a different namespace. I'm going to keep it simple, and I'm going to show you that this is the one that you should use for this course at least. If you go out and look at other tutorials, maybe even Zybooks, they'll have, they won't have type def, or they'll put the name somewhere else, and that puts it in a different namespace, and that forces you to use like struct film or something like that. I'm showing you the simplest syntax. Okay? All right. So let's go ahead and try to compile that again. Great. Now I've got a definition for a film that is composed of 2 strings, right? One representing the EIDR, one representing the title. I've got a person representing the director, and I've got another double here representing the rating. You can see that we've got a hierarchy here. We've got a film that is composed of 4 different things. One of those things is composed of 3 other things, right? And that third thing there is composed of yet another 3 other things. So we've got a box within a box within a box. Let me go ahead and show you another example here. This is from my book. This is representing a student. There we go. So if I have a structure representing a student with an NUID, a first name, a last name, a GPA, and say a date of birth might have a month, day, and a year. I've got a box, and inside that I've got another box. And with the film example, I've got 3 boxes. I've got a box within a box within a box. We call that composition. One box is composed of other elements. The first name, the last name, and another box. That box is composed of other elements. The day, month, year, etc. Question?
How would you call this?
It's a good question. So how do we use it once we've defined it? Right? And we'll come up with that here in a second. Before we do, though, I want to draw your attention to the way that we did date. Your answer of a string is not wrong. In fact, a lot of computers do that. It's the ISO, what was it? ISO 8601 standard. I type it right, 8601. There we go. It's an ISO standard, an International Standards Organization standard, and I'll have to zoom in here. There is the typical way of representing it as a string. Year, hyphen, month, hyphen, day, all with leading zeros to make sure that everything lines up perfectly. Then if you've got a time, you have a T, and then you give it in 24-hour time along with up to, I think you can go up to 1,000th of a second. And then you can also append a Greenwich Mean Time offset. Right? So that's one way, another way of representing time. And one has advantage, time and date. One has certain advantages and another has different advantages. For example, right now, the disadvantage of using 3 numbers is there's nothing to stop me from defining 2021, February 02, and 31st, right? But there's also nothing to stop me from creating a string with an invalid date. There is a third way that you can go ahead and represent a time, and that's with Unix time. So what time is it right now in Unix time? There's the current time, at least as of a couple of seconds ago. 1635373301, right? It's a clock that's been counting the number of seconds or milliseconds since January 1st, 1970. That's known as the Unix epoch. So we've got multiple different ways of representing time. You can, let's see, yeah, Unix time right now. Maybe this will have a counter that'll actually keep going up here. Right? There we go. There's the Unix time. Oh, it's not, come on. You can't update. If you hit refresh, it'll update. There you go. But it's the number of seconds since the Unix epoch. Now, you might actually ask yourself a question. Wait a second. What happens when we run out of numbers? Sound familiar? Most of you might not have been born, most of you might have been born after that, but what is it called? The Y2K bug. Why? Because they only used two numbers to represent the year. So when it got to the year 2000, it rolled back to 1900. So, did we not learn our lesson here? No, we didn't. And now there's the 2038 problem. Right? In the year 2038, any Unix system that is using only a 32-bit signed integer. By the way, you can go back in time before 1970 by using negative numbers. But any computer that is only using a 32-bit signed integer is going to have problems in about 17 years because it's going to become 68 years or whatever before the Unix epoch, so it'll become 1902 or something like that for those computers. Now, if you've got a computer, most computers are going to be using a 64-bit number here. You're good for another few trillion years. So just kick off the problem down for those the trillion-year people from now on, right? From now, right? All right. So alternative ways of dealing with time. But again, the first question you ask yourself and the first question you answer is there something to represent it already for me? Is there a time library? And indeed, there is a time library, but we're not going to use it because I want to show you structures. Okay. All right. All right. So defining structures. Let's make some observations here first. Well, here, actually, first of all, let me go ahead and cut and paste this so that you have it in the notes. And then we'll make some observations. Right? Observations. Right? A structure is composed of multiple pieces of data. Right? This is known as composition. Right? And we actually use that term, even in object-oriented programming, we'll use that term. Structure can be composed of other structures. But then order of declaration matters. It becomes important. Right? Each variable inside a structure is a field or member variable. Sometimes they're also called components. Right? You can, may want to designate by convention a unique identifier. For example, social security numbers or NUIDs, or what did we call it? EIDR, right? Or if it's a book, how do you designate a book? It's ISBN, right? Etc. Styling or conventions. What we're going to what I was using for the names should be upper camel cased. Right? You should not pluralize them. You should name them after what they're modeling. Don't call your film structure a book, right? That doesn't make any sense, right? You can call it a movie if you want to, or a talkie or whatever, but then use something more, acceptable. Names of member variables use lower camel casing conventions, right? And you saw that, right? That director, IMDb. Now, This is a coin flip. EIDR. Well, that's an abbreviation, or that's an acronym, right? So EIDR, is that how you should do it? That looks icky. Should you do EIDR? That looks even ickier. EIDR. Among all the bad choices, that's probably the least worst, right? So that's what I'm going to be using. IMDb similarly, because when nobody says, oh, maybe you should log into the Internet Movie Database, right? They don't say that. They say log into IMDb. Right? All right. So lower camel casing conventions. You use type def, struct, and opening, closing curly brackets with member variables ended with a semicolon. It is not the same thing as an enumerated type, because it's not. It is a list, but it's not like an enumeration of a list, right? It's not a cake and ice cream and donuts, right? Cake, comma, ice cream, comma, donuts. And also we'll have pizza next Wednesday. If you didn't see that in Bits and Bytes, stop by. It's the student advisory panel. So I'll be there. You can come and ask questions about the School of Computing. You can come and make suggestions on improving the School of Computing, etc. It's next Wednesday, 11 to 1, free pizza. Right? I'm sure that you get 1 million free pizzas every week. Right? That's the go-to anyway. All right. You provide the name of the structure, you followed by a semicolon. All right. So again, order matters. Usually, structures are declared in a header file with a similar name. I didn't do that, so let's go ahead and do that now. So primarily, I am modeling a film here. Right? I could go the full 9, and I could define 3 different header files: one for dates, one for people, one person, one for film, and then I could bring them all together and include them all. I'm not going to go that far. That's only really if you have need for another person, like an author, because you're doing a book over there somewhere. Maybe then you have a use case for switching it out into its own header file so that you can use it in multiple pieces of your code. We don't. That's kind of a. Oh, here. That's a YAGNI. So are you familiar with YAGNI? YAGNI. You ain't gonna need it, right? So don't prematurely optimize things, right? If down the road you find, oh, okay, I have use of this person structure in multiple different places, then go ahead and separate it out into its own header file, and then refactor all of your code. But until then, you ain't gonna need it, right? So YAGNI, you ain't gonna need it. Don't prematurely over-design your code, okay? So I'm going to take all of this stuff and separate it out into its own header file. What should I call this header file? What is it? Primarily, what does it represent? A film. So I'll call it film.h. Lowercase f, because that's the convention with file names. Right. Cut, paste, there you go. Over here, I'll go ahead and include it now. Include film.h. There we go. And GCC it, and you see that it's the exact same thing. But my main code here is not cluttered up with all those details. They're packed away over in this other file, and if you need to work with it, go over there. Right? Excellent. Okay, so now that we've got structures, we need to know how to use them. Right? You can declare a structure, once defined, normally, as you would any other variable. For that, let me go ahead and go back over here and demonstrate it. How would I declare an integer? Int x. Well, it's not an integer. What is it? It is a film, f. Right? Or let's call it what it is. Well, let's play around with Dune. Right? Film, Dune. There we go. There. Now I've got a variable called Dune representing the film Dune, the 2021 film. Right? Great. How do I use it now? For example, how do I know what the title is? Did it automatically read my mind and said, oh, you meant the 2021 Dune, not the 1984 Dune, or the sci-fi miniseries Dune, right? Or the book Dune, or the game Dune, right? Highly underrated if you ever play it from the 90s. Right? All right, so I have to set those things. Dune.title is equal to Dune. There's no other subtitle or anything like that, right? Now, note here some syntax and some problems. First of all, what is that thing? If you want to know the technical name, it is the direct component selection operator. I have a structure, and then I've got member variables within that structure, in particular title. So Dune.title is how I get access to the title, that string variable. Again, it's called the direct component selection operator. But what does it look like? It's a period. And so let's shorten that up even more. It's a dot. And so it's a dot operator. Right? That's it. It's the dot operator. That's how I access things. Now, is this how I set strings? Char star foo is equal to me. You can do that, but that's not really the best practice way of doing it. That would actually set up a read-only string. And maybe that's what you want, but we're going to do it a little bit differently. How do I do this? What do I need to do first? I need to create memory for it, right? Char star, a call to malloc. And how big do you want it? Size of, I want characters, times, how many characters do I want? D-U-N-E. Is that it? And what else? Null terminating character. I'll keep it like this for now, 4 plus 1. Right? Because I'm going to show you better ways of doing it. Okay? And now once I've got that, once I've got it set up and malloc has allocated 5 bytes, D-U-N-E plus the null terminating character, now what can I do? strcpy into Dune.title, Dune. There we go. I'm probably going to be doing this operation over and over and over again. Allocating memory for a string, copying the string. What do you think I should do? Probably make a function to do this, right? And we've done that before. When we looked at strings, we created a deep string copy function. Cut, paste that knowledge, reuse it here. Or you could do what some industrious person did in their lab yesterday and RTM, read the manual. I think it's man str dup. There we go. Duplicate dup. I shouldn't call it dup. Why? What is it called? What does it stand for? Duplicate a string. So str dupe. Yeah, there we go. Str dupe. Let's read all about it. Come on. There we go. Returns a pointer to a new string, which is a duplicate of the string s. Memory for the new string is obtained with malloc and can be freed with free. Cool. Going back to the beginning of the semester, is there something that will do it for me? I presented the way of doing it manually so that you get practice allocating memory, understanding that there's this damn null terminating character that you have to always take care of, et cetera, et cetera. You know what? Let me make absolutely, before we commit to actually using this, let me make absolutely sure that it is supported on CSE, because it is not standard C. It is an extension, man, str dupe. Okay, it is there. You can use it. Excellent. So how would I do this? Str dupe. There, done. Didn't have to roll my own function. Right? Generally, you don't want to roll your own if there's one already available for you. Right? Okay, and we do use that term of phrase, don't roll your own when there's one already there. Right? What else is in Dune? The EIDR, I have no idea what it is, so I'll just make it up. 1, 2, 3, 4, A, B, C, D. Right. Otherwise, you can look it up and let me know what it is, EIDR. What else do we have to set? The director and the IMDb rating. So Dune.imdb rating is equal to, is it any good? I haven't seen it. Okay. 9, all right. We'll just say it's on a 10-point scale, 0 to 9 on IMDb. So we'll just go ahead and give it a 9 initially. Right? Most films are way too high rated. I haven't seen, unless it's really garbage, nothing gets below 5. Right? All right, what about the director? Dune.director. I have no idea how to spell it. Darren blah, blah, blah. Darren or... Isn't it? No, Dennis Villanueva. There we go. It's not Aronofsky. That was the failed Dune. Sorry. Wasn't it Jardowski or something who wanted to make it, and then he never got around to it. So how do I set their first name? Because remember, a director here has a first name and a last name and a date of birth. So once I've got the director, how do I get his first name? Remember, we've got a box within a box within a box. So if I use the dot operator for one, and I'm inside the box, what do I do to get the other things inside that box? Dot again. Right? First name is equal to str dupe Dennis. Should have remembered that. He was a Blade Runner, right? 2049. Right? All right, last name. How do I get his date of birth though? Dune dot. Now I've got a box within a box within a box. So what do I do? Director dot date of birth dot year. I have no idea. We'll just say 1980. Doesn't matter. All right, let's go with the Unix epoch, 1970, January 1st. Date of birth, year, month, and day. One and one. There we go. Uh-oh. What's to stop me from doing the 13th month? Nothing. What's to stop me from doing the 0th month? What's to stop me from doing the negative 7th month? No. That's why you bring in a library, because a library can do data validation. There is no such thing as February 30th, right? You'll never be able to get anything that's set to February 30th. If you do, then it's an error, it quits out, it returns null, and you can do error handling if you're doing this with a proper library. Okay? All right. That was one movie. Yeah, go ahead. There's no way that I could get... Oh, wait, no, I do have the chat over here. I have the chat on both computers. Thank you. That's what an EIDR looks like. Excellent. Cool. All right. So that was one movie. Give me another movie. Oh, no? What? Avengers Endgame. All right. So cut, paste. Change. Give me another movie. Avengers Endgame Part 1, or whatever the other one is. Right? Cut, paste, a bunch of stuff. Do you think that that's the correct way about going about this? Now, I want to have this functionality in a function. So let's go ahead and create a function that will allow us to create films. Right? Over here in the header file, let's go ahead and make that function. Right? So what's its return type, and what should I call it? I'm going to call it create film. Okay? What do you need to create a film? Well, you need a title. So char star title. What else do you need? You need a director, D, or director. What else do you need? What was it? In EIDR, so char star EIDR. Title, director, and finally a double IMDb rating. Right? Now, if I handed all four of these things off to this function, it will create this, create everything, initialize all the memory. It'll do everything for me. Yeah. Say what? Oh, thank you, person. Yep, thank you. All right. what's the return type going to be here? It couldn't be a film. Now, there is a problem with this in that when you return an integer, that integer is copied onto the program stack, and there's these 4 bytes that are copied and given and copied over and over again. When you call the function, all these parameters are copied, all right? But also, when you return from the function, all the return types are copied. We're no longer dealing with 4 bytes here. If you look through this, you're dealing with 8 bytes, however many bytes a person takes. Another 8 bytes here, another 8 bytes here, another 8 bytes, another 8 bytes, 4 bytes. Right? So you're dealing with a lot of bytes, right? Not a huge amount, but it's no longer a 4 bytes. Not only that, but this is not as versatile. Right? What I'm going to do is I'm going to change this so that it is a pointer to a film. I'm going to create a film on the heap dynamically, and then I'm going to say, okay, you can find your film over there. Here's your pointer to it. Go to that memory location, and there's where your film is. So that's how I'm going to do it. Okay. All right, that means I need a source file now. So touch film.c. And of course, I need to go back and do documentation, author header, et cetera, et cetera. Right? But now let's go ahead and define this function right here. To do that, I'm going to go ahead and steal a lot of this stuff right here and modify it. So the first step, not all films are going to be Dune. So what should I call my film? F, right? Or film, right? I'm just going to go F because it's easier to type. And that's not the return type. The return type is in a film pointer, so that I can return F down here at the bottom. Now, at this point in the program, on line 6, what is F pointing to? It's just pointing to some random memory location. Dead beef, memory location that doesn't belong to me. So what do I need to do to make it point to a valid film? Malloc. I could initialize it to null and then call malloc, but I'm just going to do it in one shot. So malloc returns a generic void pointer. How do I take that generic void pointer and turn it into a film pointer? Film star, right? No puns intended with this stuff. Right? Malloc, how many bytes do you want? Well, if I wanted one integer, oh, well, how many films do you want, first of all? Just one, right? How many bytes does a film take? Well, if this were an integer, you'd say what? Size of int. It ain't an integer. What is it? It's a film. Size of film. Compilers are dumb, but at least they can look at your definition and go through and say 8 bytes, 8 bytes, 8 bytes total, and add these all up. Okay, that takes 48 bytes to represent a film. Right? And the compiler can take care of that for you. This 1 times is not strictly speaking necessary. I'm leaving it in there, though, to drive home the fact that we're only creating one film dynamically here. It's not an array of films. All right? All right, now I will go, you know what, I'm going to go ahead and get rid of most of this for now to see what it looks like when we compile. I will go ahead and compile film.c, and, oops, what do I need to do? I need to include everything that I'm going to use. So include stdlib.h, include probably stdio eventually, include the string library eventually, and of course, I need to include my own header file, include film.h. Should be happy about that now. Yep, it is. Right. Now, obviously, I haven't set anything yet. So let's go ahead and try to set the EIDR. I was given the EIDR. Let's go ahead and set it. f.EIDR, EIDR is equal to, and I'm going to do the same trick here, string dup, whatever, okay? And EIDR, there we go. Let's try to compile that. Error, F is a pointer, and ignore that, that's a spoiler alert. Right? F is a pointer. Can I use, I was using the direct component selection operator, the dot operator, when I had a regular old film, right? Over here in demo, I have a regular old film, and therefore I can use the dot operator. I don't have a regular old film over here. I have a pointer to a film. So how do I get that regular old film? Careful, ampersand it goes from a regular old variable to a pointer variable. Right? So dereferencing that. Then I can use the dot operator. The problem here is when you look under the hood, these have different orders of operations. Just like multiplication has a higher order of operation than addition, the problem here is that that dot operator has a higher order of precedence than that dereferencing operator. So I am forced to surround this with a parenthesis to elevate that dereferencing operator above the dot operator. Looks kind of ugly, right? Thankfully, there's some syntactic sugar that allows me to do something shorter. Oops, there we go. Hyphen and then a greater than. Now, again, the technical name here is the indirect component selection operator. But what does it look like? Arrow, so we'll call it the arrow operator. When you have a pointer to a structure, it's the arrow operator. When you have a regular old structure, it's the dot operator. All right? Great. Now I can do the rest of them too. F, title is equal to strdup of title. At this point, I'm going to observe, wait a second. This makes a deep copy for me, right? Am I making changes to the EIDR that I was given or to the title that I was given? Maybe there's a better way that I could redesign this so that I advertise and make the promise that I will not be making changes to these strings. Const. And const. Now, of course, that means that I'm going to have to make the same change over here to this. Const char star. There we go. All right. Now let's go back and make sure that this piecewise is going to compile, and we're good. So continuing with the rest of them, it's not dune.imdb rating. It would be f arrow imdb rating. And it's not just going to be 9, it's going to be what you were given. It seems tedious to take these variables and just assign them to the same variable of the same name, but within a structure. But once you've written this one function, you never have to do that again. Right? So, yes, it is tedious writing it to begin with, but after that, you're good. Right? And then finally, we're given the full director here, so the director will simply be that director. And and then that's it, right? The director already has the data burst somewhere in them, right? And that's it. We return F. Let's go ahead and go back over here and try to create my new film here. Film star Dune, right, is equal to a create film, and then I'll simply pass these in as arguments to that function instead. Dune, and then I need the director. What was this? Dennis, there we go, and then 9.0. And of course that means that I'm going to have to make Dennis Villeneuve up here. Right? To do that, I'm going to show you another syntactic trick. Right? I want a director, right? And I'll call him Dennis. Right? You can use the following syntax to set all of those fields all at once if you really want to. All right? The first name would be Dennis, comma, Villanueva, comma, and then within that you have a date of birth, which is going to be 1970, comma, 1, comma, 1. Right. This is off the top of my head, so I could be wrong. Let's find out. I've already compiled film, so gcc film.o and demo.c. How do I do my initializers? I'm going to have to check my notes. I swear you could do this. Anybody read my book? Okay, let's RTM, C, in declare initialize structure. Should just, I mean, I'm really close, I thought, but maybe not. dot, dot, dot. Yeah. What are you complaining about? That's exactly what I did. Fine. Okay, I'm just going to leave this as a to-do. To-do. There we go. And I'll come back and fix it later. But otherwise, I'll go ahead and just pass in null here. Right? Doesn't matter. All right, so I've got Dune now. How else could we play with this? What else would we want to do with this structure? No? Maybe we'd want to, I don't know, print it out? Okay. Let's go ahead and create a print film. Right? Yeah, we've got plenty of time. Right? So it's going to print it out to maybe the standard output. So void, print film. Right? And we'll take a film. We'll take it by reference. Right? Because again, if you take it by value here, every single piece of data on that film is copied into the program stack. It's not that big of a deal with what we've just done because it's only going to be less than 100 bytes. But think about a situation where your structure might be many orders of magnitude larger. In fact, maybe it contains data like the actual film of Dune as an MP4 file, right? Are you going to be able to copy that onto the stack? No way, right? So I'm going to go ahead and pass this by reference so that I'm only passing a pointer through everything. Okay? Now let's go ahead, and of course, documentation, documentation, documentation. Right? There we go. Let's go ahead and print it out to the standard output. How do you want to print it out? Printf. Maybe the title, right? Directed by the director, last name, comma, first name, right? And its release date or whatever else we did, and its IMDb rating. Let me go ahead and put in the IMDb rating in here in just two of these. We'll forget about the rest of it, right? We don't care about the director's birthday for now. We don't care about the EIDR for now. This is just one way of printing it out, okay? And then we'll go ahead and end the line. We'll print all that information on one line. If you want a different format, make a new function with a different format, right? All right, how do I print each one of those things? How do I print the title? F, title, right? Why did I use the arrow operator? Because I was given a pointer. Now here's another interesting question. Am I going to be making changes to the film? So how can I advertise the fact that I will not be making changes to the film? Const. Const char star, no different with const film star. Right? Okay. And now, what about, and I'll go to the next line here, just so I don't have long lines. You can do that if you want. Go to the next line, indent a little bit. F, director. Ooh, now, dot first name or arrow first, I guess last name is what I want first, right? Dot or arrow? Let's try arrow first and see what happens. F, director, first name, and then finally F, IMDb rating. There we go. All right, let's go ahead and compile that. Nope, it didn't like the arrow. Why? So F is a pointer. Let's jump in to F and look at its structure. Is this a person pointer? Nope. It could be. We could go back and redesign it so that we have a pointer to a director rather than the actual director here. And if you want to do that, go ahead. It's a good exercise. Then you would use arrow, 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 arrow instead of dot, 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 dot on everything. But for now, I'll just go ahead and leave it as it is. And we'll understand here, because that director is a regular old structure, we use the dot operator here. Dot and dot. Let's see if that solved all of our woes. Nope. Print film, print film. Oh yeah, because I changed it to a const. I need to go back to the header file and change it to a const. Now they agree, and I can compile it. Let's try it out. Once I create a film, in fact, just let me show you Why this is called a factory function? Why is it called a factory function, do you think? Because it manufactures films, right? Dune, you said what, end game? Okay, and to do, I don't know what it is. Is it Avengers end game? Like that? Okay. Is it I think I saw it a while ago, but is it any good? No? Yes? 9.9, okay. Yay. All right, now let's go ahead and print those out. Print film, Dune, and then print film, endgame. .o and demo.c. Uh-oh. Darn it. All right, I'm not going to be able to pass in null. Fine. I'll do it your way. Director D, and I'll just put in D there. And Dennis Villanueva did both. Come on, really? Director D. Person, aka struct anonymous. Where are you? Oh. Person D, thank you. There we go. I keep messing it up. Sorry. There, Dune directed by blah, blah, blah. Dune directed by blah, blah, blah. Why? Because I never said anything there. What is that? It's the dead beef garbage that was whatever is in that memory location. Right? 1 HPT, I have no idea what that is. 1 hit point to lose? I don't know. All right. So, that's pretty good. What if I wanted to print this out to a file, though? What if I wanted to print it out to a socket to send it over to IMDb because I'm submitting my own review or of some sort? What if I wanted to print it out to whatever, to the actual printer, the dot matrix printer, and it starts... Right? Probably need a new function, new function, new function, new function. How could I make it so that I have one formatting function that then you can, here's a string. Go ahead and print it out to your dot matrix printer. Go ahead and print it out to the file. Go ahead and print it out to wherever the hell you want. What if I created, instead of printing just the film, what if I created a char star film to string function? Right? What might that look like? Virtually the same thing, but instead of printing to the standard output, should I print to a file? Or should I print to a string? Do you remember sprintf? We briefly discussed that when we looked at strings and formatting. But you can do that. You can print it to a string, s. Of course, I need a string, char s. I'll just make it big enough, okay? And then I will return s. Right. Now there's a problem with this. Hopefully you've noticed it already. We'll fix it in a second. But before I do that, now that I've got that, what could I do? I could say char s, char star s is equal to film to string of f, and then I could print out just that stuff, right? S. Now there's a problem there too, right? But let's take care of the first problem first. And let's let the compiler tell us what that problem is, with all the warnings associated with film.c. Warning: function returns an address of a local variable s. Right? Yeah, what could we do? How did I declare s? I declared it big enough, right? But it's a static declaration. Where is that static declaration created? On the program stack. Remember the program stack? You call a function, call a function, call a function. That stack frame, that's where the string is. So when you return back from this function to print film, what happens to that stack frame? Goodbye. Right? So I can't do that. I can do a combination though. Char star result, call malloc, char star malloc. Actually, should I even bother calling malloc. What's the trick that I just learned? str dupe. Duplicate my string for me, please. Set up the memory for me, please. Go ahead and copy it for me, please. Thank you. And return result. Now, you do run a risk here. What if you have a combination of titles along with first names and last names that all are greater than 1,000? Then it's going to overflow this buffer here. That is definitely a risk, but it's a risk I'm willing to take for now. Right? If you want to be less risky, 10,000 is fine. If you want to be super, super risk averse, 1 million is okay. Is it? That's 4 million bytes. That's 4 megs on top of your stack. You've just risked a different risk of piling dishes upon dishes upon dishes until it overflows, stack overflow. Right? 1,000's good. Right? Now, if you really wanted to be pedantic about it, what you could do is you could go ahead and say, what's the string length of the title plus the string length of the last name plus the string length of the first name plus 1, 2, 3, 4 characters for this, plus all of the formatting characters, and get it exactly right. Right? And then you can don't use strdupe, you use malloc directly. Right? Again, it's a Yagni. You ain't gonna need it. 1,000 is good. Right? Now there's another problem down here. It dynamically creates a string representation of my film. Right? Avengers Endgame directed by 1 hit point to lose, et cetera, right? And then I print that out to the standard output, but what do I do with it afterwards? Nothing, right? What happens to it? It's a memory leak, right? In fact, this will compile GCC film.o and demo.c, great. A.out works perfectly fine, but when I run through valgrind, A.out, valgrind, A.out, I'm getting a whole bunch of errors. Definitely lost, it's only 242 bytes, who cares? Definitely lost indirectly lost 64 bytes here. Those are going to be my duplicated strings, right? And let's see, so remember those two numbers, 242 and 64 lost. Let's see if we can get that down just a little bit by freeing the string before I return. All right, so GCC, film, GCC, everything else, run it through valgrind, and it's much less. Right? Now, where is the remainder of my memory leaking from? From demo here. Dune and Endgame were dynamically allocated. I would need to free those up, right, after I'm done. If you really wanted to do this, free Dune. And a lot of people have been doing this in their testers. It's not absolutely necessary. We certainly don't take off if you don't do this. Endgame, there we go. There's still going to be a memory leak here because, let's run it through valgrind again. All right, I'm still losing about 64 bytes, but not indirectly. Why am I losing 64 bytes? Let's take a look at the film.h. What else was dynamically allocated? The EIDR and the title. What else was dynamically allocated? The first name and the last name. None of this was dynamically allocated. So if I wanted to free completely the film, what would I have to do? I would have to go inside the box, inside the box, inside the box, and free from the inside all the way out. I would have to go in and free the first name, free the last name, then come outside that box, free EIDR, free title, come outside that box, and then free the film finally, right? That sounds complicated enough that what should you do? Make a function to do it for you. We're out of time to do that. I'll leave that as an exercise over the weekend to have some fun with it. You're not going to have fun with it. All right. Have a good weekend anyway.